Welcome to Part 2 of Chapter 5's instructional video for Business Finance. In this video, I'll talk about annuities and amortization. So let's first look at an ordinary annuity. In an ordinary annuity, equal payments are made over a period of time. Those payments are made at the end of a period. So in this example, $1,500 is deposited at the end of each year for 6 years. So in an ordinary annuity, the same amount of payments are made at the end of each period over a set period of time. And in this example, it's 6 years. So let's look at the formula for an ordinary annuity. We have future value, which is going to be the future value of the annuity. We have PMT, which is the payment that is made at the end of each period. We have I, which stands for the interest rate per period. And we have N, that stands for the number of periods in the term. So in this problem, Alice deposits semi-annual payments of $3,200 in an ordinary annuity at 6.8% compounded semi-annually. Find the final amount in the account and the interest earned at the end of 3.5 years. So I'm going to pull out the information that I know. I know that she's making payments of $3,200 twice a year. So my PMT is going to equal $3,200. Now let's find I. I is equal to 0.068, which is the rate, divided by the number of times it's compounded per year. In this case, it's compounded twice per year because it's compounded semi-annually. So it's 0.068 divided by 2. The N in this case is going to be the time in years, which is 3.5, times the number of times compounded per year, which is 2. So there are actually 7 periods in the term. Now we're ready to plug everything in. So the payment is $3,200, and then put a big bracket around your fraction. On the numerator, you have 1 plus I, and I is 0.068 divided by 2, raised to the n power, and n is 7, minus 1 divided by I, and I is 0.068 divided by 2. So our strategy is going to be to find our numerator, then find the denominator and divide the two, and multiply the result by 3,200. So we have 3,200 times, I'll find the number for the numerator first. So we have 0.068 divided by 2 equals, plus 1 equals, raised to the, so y to the x, 7th power equals, and then minus 1 equals. So in the numerator I have 0.2637. And again, you want to try to write out as many decimals as you can, because the more decimals you write out, the more accurate the number will be. In the denominator I have 0.068 divided by 2, which is 0.034. So lastly I have 3,200 times 0.2637 divided by 0.034, which is 7.7559. And that gives me a total of $24,818.82. Now if you come out with, say, 76 cents, it's going to be close enough. So just make sure that you just keep as many decimals in your calculator as you can. But the answer here means that if you invest $3,200 every 6 months for 3.5 years, you're going to have $24,819. So let's look at another example. Ian, a 30-year-old, invests $250 per month, so the same amount every month, that's going to be the payment amount, in a Fidelity Equity Index Fund which has an average return of 9%. Estimate what he will have at retirement when he is 65 and assume monthly compounding. And so the investment is going to compound once a month or 12 times per year. So let's pull out the information. PMT is going to equal $250. I is going to equal the rate, which is 0.09, divided by the number of times compounded per year, which is 12. And N is going to equal the number of periods in this term. Well, he starts investing at 30, and he wants to know what he has at 65. So if he's compounding 30 years, and the number of times compounded per year is 12, that means that there are 360 periods in this term. 360 months that the payment will be made and that the investment will be compounding. So now let's plug everything in. The future value is equal to the payment, 250, times 1 plus I, and I is 0.09 divided by 12, raised to the n power, and n in this case is 360, minus 1 divided by I, which is 0.09 divided by 12. So again, the strategy is to find this top number by putting 0.09 in your calculator, dividing it by 12, adding 1, and raising it to the 360, and then subtracting 1. Find that number, divide it by the bottom number, and multiply it times 250. So try this on your calculator, and then you can compare it to the number that I have. So the answer that you get should be $735,446.12. How close did you get? If the number is a lot smaller or a lot larger than this number, you might try it again. But the reason why this is pretty large for a retirement account is because of the interest rate, 9%. That's a pretty high interest rate for an index fund right now. So in our next examples, we'll be looking at amortization. And what amortization is, it's calculating the payments that you make on a loan. The payments that you make will be comprised of interest and principal. This is a mortgage at $300,000 at 5% for 30 years. So some of the payment will be principal, but most of that first payment will be interest. Then as you go along making payments on the loan, the amount of principal that you pay will be higher, and the amount of interest in your payment will be lower. So in our amortization problems, we're going to be calculating what that payment amount is. The payment amount is going to be the same throughout the life of the term. So in our formula, we have payment, PMT. We have PV, which is present value, and that's going to be the loan that you take out. We have I, which you've calculated before. I is the rate per period. And then we have N, which is the number of periods in the term. So you would like to buy a house and want to know the payments on a 30-year loan for $200,000 and 10% down. Interest rates are at 4%. Assume that you are making monthly payments. What is the interest paid on the loan? So let's first find out what the payments are, that payment amount, PMT. I'm going to pull out the information of present value first. So present value is going to be what the loan amount is. And notice that you're putting 10% down. So 10% of 200,000 would be 200,000 times 10%. And you can put 10% here or convert it to a decimal, which is 0.10. And that equals $20,000. So you're going to be putting $20,000 down in cash, and you're going to be taking out a loan of $180,000. So $200,000 minus $20,000 is equal to $180,000. That's your loan amount. So PV equals $180,000. I is equal to the rate, which is 0.04 divided by 12 because you're making monthly payments. And N is equal to the number of years, which is 30, times the number of payments per year, which is 12. So that's 360. So let's plug everything in. The payment amount is equal to the present value, which is $180,000, times I, which is 0.04 divided by 12, divided by 1 minus 1 plus I, which is 0.04 divided by 12, raised to the negative n power, negative 360. So don't forget that negative sign. So our strategy then is to find the top number, the numerator, to find the bottom number, denominator, and then divide the two. So the top number, you're going to put in your calculator 0.04 divided by 12, and then equals. And then multiply that times 180,000. So my top number is 600. Now the bottom number, using order of operations, means we have to go into the parentheses and calculate that first. So in the parentheses I have 0.04 divided by 12, hit equals, plus 1 equals, and then I have to raise that to the negative 360 power, so y to the x. I put 360 in my calculator and then hit the plus or minus sign, and then equals. So I have 1 minus 0.301795. I'm going to go out as much as I can with those decimals. So that equals 600 divided by 0.698205, which is $859.35. This is the monthly payment that you would have to make on a mortgage of $180,000 at 4%. So the question says, what is the interest paid on the loan? Well, I know that the payment amount is $859, so I need to multiply that times the number of periods in the loan. So $859.35 times 360. So I multiply it times 360 and I get $309,364. Let's say $65. So after you make all of the payments, those 360 payments, for 30 years, you would have paid $309,000. Now, if I subtract my loan amount, $180,000, this is the amount that I'm paying off. That gives me $129,364. That means that I'm paying $129,000 in interest over the course of the loan. That's a lot of interest being paid, but the term of the loan is pretty long, so it adds up over time. So let's try one more problem. You decide to take out a car loan for $10,000. Use the interest rate of 2.9% to calculate the payment for a 3-year car loan and a 5-year car loan. Assume monthly payments. So I need to first pull out a PV, or the amount of the loan, which is $10,000. I have a rate of 2.9%, so that means my I is going to be 0.029 divided by 12 because I'm making monthly payments. And my N is going to be, first let's do the 3-year, so N is going to be 3 times 12, which is 36. I'm making 36 payments. So my payment amount is going to equal PV, the present value, times I, which is 0.029 divided by 12, divided by 1 minus 1 plus I, 0.029, divided by 12, raised to the negative n power, so negative 36. So try calculating this on your own, and then compare your answer with the one here. So the top number should be around 24.16667, and the bottom number should be around 0.08323, which gives you a payment of about $287. Now that's a payment for 3 years. To calculate the payment for 5 years, you're simply going to change the exponent. Instead of 36 periods, you're going to have 5 times 12, which is actually 60 periods. So replace this 36 with 60. So after you calculate that out, the payment after 5 years is going to equal $176.07. So you'll notice that by extending the term out from 3 years to 5 years, you lower your payments by about $100. You're lowering your payments, but in fact, over the term of each loan, you're paying more interest on the loan at 5 years than you are with the loan at 3 years. Practice calculating these figures again in order to ensure that you get the same answer. Then try working on your worksheet.